The there we go. Should now have got a message to say it's going to be recorded, and this will be the recording that goes out to everyone via the emails as well. Excellent. Great. So let's have a look at what we will be covering in today's training. So there, it's broken down into these three main categories. So we'll look at reducing energy bills. We'll look at renewable energy. So just looking at two main sources there. So solar panels and heat pumps. And we'll look at how you might want to go onwards in terms of getting further information or linking out to different people in your communities, some little tips and some actually really useful information on grant funding so that you're well equipped with where to signpost people out to. Okay, so the purpose of the training, obviously we don't need to know everything off by heart at all. That's not what this is all about, but it's hopefully giving you the ability to feel like you've got the basic foundation, that when you're talking to residents, that you've got the confidence in talking around some of these topics, and that you're a bit more familiar with some of the terminology or some of the solutions that you might want to be talking to people about. And like I say, you don't necessarily need to make notes, you're more than welcome to, but we'll be sending the presentation out afterwards with all of the slide notes and extra bits and pieces that go alongside this. So if you do want to come back to it, if something triggers in your mind a little bit later, that's not a problem, and it'll be easy to go back to and flick back through. So the main purpose of this training, obviously, as we're saying, to give you the basic guidance to be able to signpost people to the different bits of information who you would have met during your surveying of the thermal imaging project, and really don't underestimate the importance of actually signposting alone. I think when I've been and done similar projects myself, and I've kind of been on the other side of things, I think I start conversations with people and I feel like I should be the expert for everything that the conversation might then lead to, and that's just, yeah, it's not the case. I mean, it's great if you do have more knowledge that you can back it up with similar examples or some personal experiences perhaps, but simply giving some basic guidance, some introductions to different topics really goes a long way. And then by the end of the session today, we hope that you'll be able to give the simple advice, and it can be about obviously reducing energy bills, it can be about improving the actual efficiency of homes, potentially talking about what renewable energy options they might want to go for, and where they might want to go, obviously, for this information and further funding onwards. Any questions at this point? Sounds okay. Okay, great. Perfect. I'm just going to check the Q&A because I can see a few things popping up there. Okay, I'm just going to change to panelist options. So Dee, I think you've joined. Yeah, you've joined now. Marion, I'm going to invite you to become a panelist in a second. Sonia, do I need to know about the thermal imaging cameras? So there's two parts of the training, which this might have covered in your question or my answer a little bit earlier. There's two parts of the training. This is about the kind of adaptations that you might want to be recommending. The other training will cover the thermal imaging camera aspects of it, so interpreting the images. Hopefully that answers your question. And to the anonymous attendee at the bottom, does it mean that you're in the wrong seminar? It doesn't mean that you're in the wrong seminar if you were wanting to join for the thermal imaging camera session. This one focuses on changes, as we were saying, in the household. Ideally, it's recommended that you attend both, but if you would rather watch the recording of this session and attend in person the thermal imaging camera session, which will be Jess, I think it's the 6th of November, isn't it?
Yeah, that's right, next week.
Excellent. That's also fine, but you're not necessarily in the wrong place, don't worry. Okay, right, I'm just going to go back to Monica and invite as a panelist. Lost you on the list, Monica. Sorry. Maybe you've disappeared.
I think it was Marion.
Ah, was it Marion? Great, thank you. Well done. There we go. That you should have just had a option to join now. Perfect. Great. So hopefully everyone knows where we all are and why we're here. Okie dokie. So to put this in a little bit of context and think about the wider picture and why this is important, we're just going to have a look at this snapshot from the Suffolk Climate Emergency Plan and talk a little bit more widely around this. So obviously by making homes more energy efficient, it obviously reduces residents' energy bills and reduces carbon emissions. It contributes towards Suffolk's ambition as a whole to become net zero by 2030. And obviously in tandem with this, there's the Suffolk Climate Emergency Plan, which details a lot of different actions as to how we want to start this journey and actually reach our goals along this pathway. This image is actually taken from that Suffolk Climate Emergency Plan, and it shows at the bottom there five of the 5 key themes that run throughout that plan. So it kind of helps focus different actions within those 5 themes. Obviously, I've mentioned that the ambition for Suffolk is to become net zero by 2030. And within the plan itself, contributing to how we're going to achieve that, there's actually 48 actions across 5 themes, the 5 themes that we see there. So there's lots of different streams of work that are all contributing towards this. And then where the thermal imaging parts fits in, which is actually into the wider plans, like beyond these and within everything else that actually goes into reducing Suffolk's carbon footprint. So if you look through the plan, you can see that the thermal imaging project is mentioned there, and actually some of the stats of how many people it's already reached and how much difference it's already making. So yeah, thank you for being part of the next part of the project and making it reach even more people in its journey. So when we look at a little bit closer to home, that's Suffolk as a whole, but our impact on our carbon footprints a little bit closer to home, it's really important to understand what we actually mean by carbon footprints. So hopefully it's a term that some of you may have come across already. Is this something that a lot of you are familiar with? Yeah, some thumbs up there. Okay, great. Is there anyone that maybe is a little bit new to the idea of carbon footprints? Sounds like very familiar things. Okay, great. So I won't concentrate too much and spend too long on this, but just want to make sure that we're all up to speed with the simple terminology and what we mean from this. So carbon footprints are in themselves a simple, useful tool to understand the impacts of our choices and behaviours. It could actually be calculated for individual levels or household levels or organisation levels. Sometimes you can get product level carbon footprints. And it's helpful because it breaks the emissions down into different clear categories, which helps us understand like where we are having our biggest impact so that we can actually target what we want to do in terms of where we're having the most impact or not. Carbon footprints themselves are expressed in terms of CO2e. You can see in the middle of the slide that term and how it's presented. And there's a lot of stuff that goes behind this figure, but simply shows in that one figure and it accounts for all of the different greenhouse gases from all different emission sources and puts it into one simple impact number almost, so that you can compare between different sources of emissions. And we don't necessarily need to understand all the different gases that it contributes to making up that carbon footprint, or CO2e figure that we see written down and reported. But we just need to be able to compare numbers and help to put things into perspective about our impact. So if we think about actually carbon household based carbon footprints, we can look at some of the figures on the left-hand side. So for an average UK house per year, we can expect 10 tonnes of CO2e as their impact. And if we think about where we need it to get to, the 2050 target of becoming net zero by that point of a UK target, we need that 10 tonnes to go down to 5 tonnes. So you can see there that we need that to reduce by half. Obviously, that's a very distant target that we're going to reach. So it seems a lot, but there's going to be lots of different measures that help us get to that point. And then when we think about where all those emissions come from, obviously, where we're looking at household level there that we've just spoken about in some of those figures, but actually when we're looking at why we're looking at households in terms of the UK's emissions, it's 40% of the UK's emissions actually coming from households. So when we're looking at this project, it's actually quite important to focus on our households and how we're reducing our carbon footprint. And when we look over onto the right-hand side of the screen and look at the actual house, it's really clear when we see 31% of our heating in our carbon footprint being taken up by heating. We can see why when we target households and then heating, actually, we can make a big overall difference. You can see the other elements to an average footprint there. You can see, obviously, there's a big part being taken up by transport, a big part by how we travel, and then other bits about how what we decide to eat. Yeah, our electricity, where that comes from, but that's a lot of that is via the grid, which is decarbonising every year and as we speak. So yeah, I think the importance of just looking at these figures is to say really that this project and your actions really do make a big difference. So then last slide that we'll have a look at before we look at some of the changes that will be you may want to share with householders is this map, which shows Suffolk in this patch anyway. We've highlighted some kind of key areas so that we can kind of get our bearings on where we are. And it shows a range of different carbon footprints across the county. So it's taken from a website called Carbon Place, and you can interrogate the data quite a lot. I'd recommend going onto it if this type of thing excites you or interests you. But we've got their grades. It basically ranks households and areas on grades A to F, A being a good carbon footprint and F being the worst. And they take a wide range of data to actually be able to come up with this grade system. So it can include things like fuel usage, transport data, EPCs, which I'll mention again in a second, and other research. And they actually come up with a grade system which they feel is like a representative view of how carbon footprints may vary across the county and country as a whole as well. And I think it's quite interesting when you look into the patterns that you see and actually the kind of disparities between different areas of what's going on. Is it to do with how the energy is everyone on oil-fired boilers potentially? How accessible is public transport in those areas? How densely populated are we? There's loads of different factors, but it really helps put things into a little bit of perspective of actually the things that can influence us and where we sit within the context of the county. I mentioned that term a little a minute ago about EPC, and that is the Energy Performance Certificate, which rates our households on the energy efficiency of our building, of our property, and it rates it on a scale of A to G, with A being the most efficient. And you'll see this often when a house is sold or let. And you can actually go onto the government website using your postcode and find what the EPC of your home would have last been at the time of that it was carried out. Obviously, it won't take into account any changes that you might have been put in place, but it helps put a little bit of context to what you currently have in place, if you don't already know that information. It can also help with understanding if you have cavity walls or solid walls, which we'll talk about in a second, and what state of different various elements of the house that you're looking at might be. So yeah, a useful resource to go to. But when we're talking about EPCs themselves and Suffolk, there's more than 62,000 properties in Suffolk that have actually thought to be the worst energy performance rating of E, Fs and Gs, which is quite shocking. And 28% of households within Suffolk are actually facing fuel poverty as well. So so important notes to kind of bear in mind when we're thinking about who we might want to be targeting and what challenges people might be facing. So I think we've got a good picture of why we're doing what we're doing and the difference that it can make and the positive changes that we can all be impacting. So let's start with talking about the different elements of how we're going to reduce energy and at the same time save carbon and money. So obviously there's this connected link between reducing energy itself, saving carbon, and in a lot of cases when we save carbon, we do save money. Not all cases, but most cases. It's important to actually understand the relationship between all of these, but also at the same time, a lot of residents will actually be a lot more motivated by cost savings than actually reducing carbon, unfortunately, just due to all the challenges that we maybe face in our day-to-day lives. So when we're talking to residents, maybe focus on the financial savings and being warmer and more comfortable rather than talking about the environmental benefits, potentially, but you might have to judge that on a case-by-case basis as you get to know the resident and what is really motivating them. We'll talk a little bit more about that at the end of the session today. So we'll look at these 4 elements in a little bit more detail so that basically we're able to talk to residents and show them how to do different bits and where to go for different information. So we'll look at insulation, we'll look at draft proofing, heating system improvements and renewables. And when we're thinking about how much difference we can actually make, when we're looking at home energy efficiency, we can actually reduce heating bills by up to 20% or more if we're looking at these changes. And when we look at what's already been done and the savings that have been made, energy efficiency measures have actually already saved average British households about £1,000 a year in energy bills. So quite a considerable difference in energy bills. Excellent. Before I go on to start on insulation, are there any questions? I'm just going to quickly dip into the Q&A and see if anything else has come up. 5-ton target, is 5-ton target for 2030, not 2050? That's Jonathan. I believe it's 2050. I will double check the source. I've got the source in the notes. So at the end of the session, I'll go back into that and pull that out and add that into the notes which we share around. Okay, excellent. Great. If any other questions has come up as we go along, please do feel free to put them in the Q&A. Okay, so insulation. Heat loss through floors, ceilings, walls in homes can all be quite significant if insulation levels aren't actually at the recommended minimum. What we kind of mean by heat loss and actually how it works and how we imagine the flow. So if we think about in winter, when heat flows from a heated living space into the outdoors, it can go into adjacent unheated attics or garages or basements. It travels through interior ceilings and walls and floors. Basically, wherever there is a difference in temperature, it will travel. And also we have to think about the kind of reverse as well. So during the summer, heat flows from the outdoors where it's hotter outdoors compared to the indoors. So it'll flow from the outdoors to the inside of the house. So it's also important in the summer to kind of keep houses cool. So it's something to bear in mind when we're thinking about insulation, the actual impacts of both. And the importance of insulation in terms of how much of a difference it makes. Typically, when we're looking at heat lost through uninsulated walls, there's a ghost on my mouse, sorry, I'm just going to flick it back. We're looking at about 30 to 35% of heat actually lost through those uninsulated walls. And when we've got an uninsulated roof, we're looking at about 25% loss, which is really significant. And when we're thinking about the difference between colder months and like summer and the actual difference of insulation, I don't know, some others of you might have examples of this to add, but I remember when I lived in a house which was it was an end of terrace house, and before we moved in, we were lucky enough to actually be able to strip all the walls, and it was a timber framed kind of uninsulated cavity, and we put so much Celotex insulation in there, like the foam kind of panels that you can get for insulation. It seemed extreme at the time, but then a few months later it turned into winter time, and we saved so much on the heating. It was you just needed the heating switched on very for a very short time. It would warm up. But then I got so worried about actually in the summertime being baking inside, that I was a little bit nervous of actually how it would go. And but I'd obviously heard how the different experience of people, but didn't quite understand how physically how it would look. And then I remember going into summertime and it being so delightfully cool inside, but we didn't have to do anything. Yeah, it was a real kind of light bulb moment for me. I think actually feeling that comfort difference, and not having to make any physical adjustments day to day, other than that, obviously that insulation change. So yeah, it makes a huge difference if we are able to change the insulation on a building. So if we look at DIY examples, so these could be easy examples of ways to reduce the amount of heat loss, so that obviously we're just kind of spending less on money when we're heating up water, or hot water. When we've got that hot water, it's actually kind of staying at that maximum temperature that we're needing it to for longer. So there's different ways of looking at this. And obviously when we're looking at fixes, we're wanting them to try and be cheap and effective as well. So when we're looking at this on a thermal imaging camera, what you might see is little patches, if we're looking specifically at heat escaping through, for example, a radiator spot. You can actually see this little patch under the window, which is a lot more warm in colour, so it's got a bit more of a red colour to it underneath the window. So we're pretty confident in that scenario that actually heat's escaping through that connection of the radiator through to the wall and out to the external environment. So what we could suggest in that situation is actually fitting, oh, I've got the ghost again on my mouse, sorry guys. We're actually fitting reflective panels for the radiator so that the heat's reflected back into the room. Very simple fix, and doesn't need to cost a lot, but they can actually make sure that it doesn't escape through the external wall and it's reflected back into the room. They're the most effective when it's installed actually on an uninsulated solid wall as well. So something just to note. And some residents may want you to obviously also kind of do the thermal imaging on the inside of the house, if you're comfortable with this. So you may spot in examples like this, if you go inside the house, things like when you're looking at hot water cylinders, potentially identifying areas of more insulation, sometimes just a visual, although you know it's going to turn up quite dark and red on the thermal imaging camera, but just sometimes visually seeing it for people can make a bit more of a incentive as to actually put in some changes and make that difference. In terms of costs, a hot water cylinder jacket costs about £15 and it's quite easy to fit, and it should be about at least 80 millimeters thick when you're thinking about how much you would actually need. Another type of DIY insulation is actually when you're looking at exposed hot water pipe insulation, so foam tubing that you can cover exposed pipes between the hot water cylinder itself and the boiler. It can actually help quite a lot. You can see examples of both of these in the photos. Yeah, we've actually in our bedroom where we are now, we've got one of these jackets and the pipework, and before it got fitted, our bedroom was yeah, when the radiators were off, it pumped out enough heat from that alone, but now we notice a difference. Obviously it's keeping the energy inside that cylinder a lot more now it's on. Perfect. Laura, you've got your hand up. Did you want to you've got an example of what one looks like, the insulation, the reflective sheeting. Excellent. Thank you. Did you want to, I'll ask to unmute you so you can chat
Yes,
about
sorry.
your,
I've
go
got
for it.
you on mute. So yeah, we've just ordered a few props to have on our stand, and it includes this roll of superfoil multi-purpose wrap. So it's kind of well, I thought that was useful. And when we come along to other things, I might just say what we've got.
It's a really good idea. What else have you, what out of interest, what else have you got to hand? Oh, a big box of goodies.
So we've got this
Oh, is that the tape?
chimney sheet. This is the chimney sheet.
Oh, yep.
Right.
Right.
It's got a handle on in there. I don't know if you can see it. It's black handle to
Yeah.
put it through into.
Okay.
Got some sheepskin draft excluder.
Nice. Yeah.
So
Yeah.
it's got just a sticky tape on there. Won't be long with this.
That's okay. I think it's really important to see this.
The door draft stopper has this it's a you can stand in the light so that it's not too bright. So it's a long sleeve sewn down the middle,
Oh, yeah.
and you put these
Like foam tubes.
through the top, and
Ah.
then there's two of them, and they slide under the door
Oh, either side.
on either side of the door.
That's really handy.
Moves with the door as it's opening,
Yeah.
and it's got this Velcro bit here
Yeah.
that you can cut these to size
Yeah.
2 or 2.5 or 3 or something, and then you tape this up with the Velcro to make it the right length of the door.
Great.
And I think it's quite neat actually, that bit.
I'm really impressed. I love a good design, like a well-designed product. And I think, and you always look at draft exclusions as like having to move them every time you open and close the doors, and that just solves so much of that. That's
It's
great.
it's also going to you know, make it, if it's going to make the carpets or just polish the door,
Oh, yeah, yeah, you might
the
have a little
floor under the
action.
door. But I don't, you know,
That all very clean in that one area if you've got a solid floor.
yes. People have probably all seen this sort of thing before. Nod if you have, if this is useful or not.
Quite Roger and
Very,
Jess have.
very useful.
Okay, so yeah, just a quick heads up to Roger. We'll be bringing this to the 16th of November event, of course. Yeah, that's the main thing. And a window insulating kit with that's a heat shrink wrapping with tape around the frame. So these are just, we're going to just demonstrate these, have these on the stall so that people have actually seen it in the flesh, so to speak, and then they can get their own
Yeah.
and work out what criteria they want to match.
It makes so much more sense. It makes it more tangible and real to people, rather than just going and explaining about something, or even in pictures. Like, it goes that one step further, doesn't it? It's really good.
Yeah.
Good idea. Thank you for sharing. Is there anything else that anyone would like to share at this point that they found particularly helpful? Feel free to also pop it in the chat if you've got a particular product to link to, if it's helpful for any other groups to know about. If you do pop stuff in the chat to anything particularly helpful, I can also amalgamate those into a helpful list to share around the group. Okay, great.
I could say just that Which this last week recommended an old towel is the best and cheapest form of insulating doors. The problem is it doesn't move with the door.
Yeah, you'd have to get inventive there, I think, as to how you might want to keep it in place. But a good existing method, if you can't afford anything to add into your house, and it kind of shows actually how little you may need as well to actually.
This is just a hint with the double-sided one that it tends to move away from the door. It moves off the door, slides outwards, and it's useful to put a bit of double-sided sticky tape on there to hold it onto the bottom of the door.
You need to recommend some improvements for the next version to the manufacturers. Excellent. Thank you for sharing those, both of you. Excellent. Okay, so we'll go on to having a look at roof insulation next. So this is quite a big and common thing that you'll see when you're looking at thermal imaging images. When you're looking at actually heat being lost through the roof space, it's a huge amount of heat that can be lost through this space. So when we think about actually what we want to do in this and the difference that it can make in households, it's really significant. So obviously reducing the heat loss, we're reducing the bills, and the actual depth that we're looking at of most insulation is about 270 millimeters depth of insulation there. That's to bring it up to current recommended standards, and the insulation, once it's installed, we're expecting it to last for about 40 years, so hopefully wouldn't then need changing for a good while. It's important to note, as I think, Lara, a lot of your products were looking at natural fibres. Something to kind of be aware of, obviously a lot of different, oh, I've got my ghost again, sorry guys, keeping me on my toes on my slides. different house types will require different insulation types. So if we're thinking about natural types, are a lot better for the ventilation and how air flows within older properties, more historic properties that are made out of much more natural fabric, whereas a lot of your kind of artificial kind of fibre insulation are a lot more appropriate for, in a lot of circumstances, for newer buildings. So just something to bear in mind, that the insulation type that you might be talking to people about might differ depending on the building type as well. Has anyone got any examples of that they might have already spoken to anyone about or have in their own homes? No, no worries. If we're thinking about when lofts obviously have been converted, so there might have been a lot of work that being done, the need to install roof insulation instead at that point, it's kind of fitting insulation material between and over the rafters. So thinking about the space in which we want to be installing that. So we're thinking about actually the sloping timbers that actually make up the roof itself. So yeah, just thinking about how that space is being used, if it's just a boarded attic that's just being used for storage, or if it's actually been converted, and actually the space that you're left with to put that insulation is a lot smaller. It can be quite expensive, but it can obviously save a lot of money, and there's different help available for this, different grant funds that we'll mention at the bottom and send out in the slides, so you can look at later. You can actually save quite a lot of money in a new offer that's actually just become live. When we're looking at typical installation costs, the Energy Saving Trust have pulled out a few examples of different households. So you've got the different households along the bottom, you've got the typical costs of installation up the side, and you can think about this is going from a household with no insulation to an insulation depth of 270 millimetres. So thinking about that difference, we can see insulation costs of about 1,100 for a detached house, whereas if it's a mid-terraced house, you might be looking a little bit more towards £850. But again, there are grant funds that can help reduce this quite significantly as well. And when we're looking at how much energy we can save, again, this is from the Energy Saving Trust website. So you can kind of click through these if you want any further information. They update these figures and charts as well quarterly, I believe, in line with the government energy price data that they share. So in terms of bill savings for a detached house, you can see savings of about £380 a year when you look at moving from no insulation to 270, and a mid-terrace house about £200 savings. So it just gives you an idea of how much you might be looking to actually see from energy bill savings. This is actually based on a gas heating system, but with the cost of oil at the moment and how oil and gas prices are, and the kilowatts that you get from a litre of oil, the savings are actually very on par between the two. Okay, any questions about roofs before we go on?
Sorry, can I ask?
Yeah, go for it.
Where exactly is this data on the Energy Saving Trust? Is it easy to find?
Sorry?
Is it easy to find?
Yes, yeah, their website is very user friendly. It on the main page, you'll see the link to this is actually in the slide notes, and which
okay.
But on the actual Energy Saving Trust website, it breaks everything down into very simple categories. So if you've got home energy, and then you go reducing energy at home, and then you go insulation, and then it breaks it down into different themes. Yeah, it's got loads of different tips and stuff on there. I'd highly recommend it. And yeah, links will be in the slide notes and at the end.
Okay, thank you.
And Jess has just put it in the
thanks, Jess.
notes as well. Thank you.
That's all right.
Great. So we'll have a look at wall insulation now. So
Sorry,
also just
before you do that,
on.
could you just put the warning out that one of the problems with insulation is often dampness, the way it's used, and in particular with the sprayed insulation that's been notorious in recent years for causing a lot of damp and actually destroying roofs. So it is necessary, I think, to warn people not to just go with somebody who comes along with what seems like an easy, quick answer and a relatively cheap one, that it can do a lot of damage to houses and make them impossible to sell.
Yeah, that's a really good point. Especially in older houses, where the air circulation isn't quite as we would expect, or the materials are a lot more damaged. There's different models for different types of buildings as to how, like open and closed types of buildings, as to how the air will be circulated. So it's not something you could easily look at and advise one way or the other. So like you say, I think making people aware of getting someone that knows the building fabric and to be able to advise one way or the other is probably your best bet.
Yes, at the edges, it's a good insulation will be finished off using perforated plastic panels, which keep air circulating above the insulation.
Great. Thank you. That's a really important point to make.
Do we need to warn everybody not to fall for this sprayed insulation then?
Oh, I've got my guys back. Sorry, I'm just going to skip back. Spray insulation is difficult because in some situations it's really worked really well for people. There's been a lot in the news about spray insulation, about, like Roger was saying, how damaging it can be if it's applied incorrectly.
It creates bridges within the building and the structure, so that something which would normally be wet but ventilated and isn't a problem suddenly becomes part of the structure, and you can't get rid of the damp, and then creeps.
Yeah,
That's the issue. And all you can do is, I think, individuals, if they're looking at it, is check and see who else has had it done and whether or not it's a problem. But it doesn't show itself for several years.
yes, and it's probably quite difficult to remove.
Yes, it's extremely difficult. You've often got to take the tiles off.
Yeah.
And and it's obviously attached to things. I've seen people having problems with it covering kind of vital services as well, and then they can't get access. It's tricky stuff. I don't think we've ever necessarily recommended it, but I know it has worked for some people. Removable insulation is probably a good thing to go down if you can. Does that help answer your question, Lara? Was it Lara?
Yes, thanks very much. Yeah.
Cool. Excellent. Great. Okay. The next thing we're going to look at, right, flick back through, is looking at what these different types of wall insulation can look like. So obviously walls are just important, and about a third of the heat can be lost through walls themselves. We can look at, in this image, just in the top right hand side. So this is kind of an image you might see through the thermal imaging cameras when we find uniformly insulated walls. So that might be kind of patchy insulation that they've got there. And insulation on walls kind of comes in kind of three main it presents itself in three main kind of typical ways. So you've got first of all, on the right hand side, if we look at external solid wall insulation, and that basically involves adding a layer over the top of your building material to the outside walls of the building, and it avoids losing any inside space, which is a plus, but it can often be a lot more expensive. And on a lot of properties, if they are of kind of listed nature, then there's they're often not actually something that can be done, because obviously it changes the aesthetic of the building. The Historic England have a lot of guidance on that, which we have listed in the notes at the end as well. So that's one type. And then the cavity wall installation, which is the next type along, basically is made up of kind of what between the two walls within a house, you've got a gap in between, which is known as the cavity. Not all houses have this, only houses of a certain period. And this cavity can actually be packed in some situations with insulation, which can help retain the heat within a home. And then the last type on the left-hand side is internal wall insulation, which involves fitting rigid kind of insulation boards to the walls internally. Could be by kind of building a stud wall or other type of wall, and then filling this in with kind of insulation material. It's generally known to be cheaper than external solid wall insulation, but it obviously comes at a cost of making rooms smaller, and it can be quite disruptive if you need to make big changes for it. Again, all of these with wall insulation, all of the different elements, Roger touched on this, need to be obviously assessed and done properly with engineers and experts in this field, because there's a lot of different elements with thermal bridging gaps of how the actual moisture is traveling around a building, so that they're actually designed to meet the requirements of each building, but just to be aware of the different types so that people can understand potential options that are available to them. The kind of typical costs that you might see for insulation are around, so for about a 3-bedroom semi-detached house is around 1,200 for cavity wall insulation. If you're looking at external wall insulation, that's about £14,000, and if you're looking at internal wall insulation, that's £10,000 roughly. So you can see actually there's quite a big cost difference between the three options. This slide really helps kind of understand what kind of wall you might be looking at of any particular house. So if you are looking at brickwork that has cavity walls, the bricks are most likely to have quite an even pattern, quite regular and uniform, which you can see there on the top left. And all the bricks are often lengthways. How to tell if you've got a solid wall home, on the bottom right picture, you can see some of the bricks have actually an uneven pattern. So you can see there's some that are smaller, some that are bigger, and that is where the bricks have been laid sideways, and that wall is solid. You've got 2 layers of bricks there. So wouldn't necessarily be applicable for cavity wall. Another way of telling cavity walls is on this picture of the bricks at the bottom. Can you see those little splodges? So this can indicate that there have been drill marks within the walls at some point, and they may have already had cavity wall insulation, and that might have been retrofitted at some point. In terms of cavity wall insulation, a lot of that is kind of applied for houses that have been built between 1920 and 1970s. But yeah, a lot of this information you won't necessarily need to know in detail, but just maybe something to be aware of if questions come up, if you feel comfortable with trying to look at what their situation might be. Any questions before we move on? Lara, did you have a question?
Oh, sorry. Regarding the cavity wall, holes that are a giveaway if the cavity has been filled since it was built. While I was doing my training to become a domestic energy assessor to do energy performance certificates, I was told that if we look at the outside wall, that and it's best to see this in daylight, of course. The drill holes are actually in between, in the corners, the T corners, right in the T corners there, and usually on the same row, maybe a couple of meters apart, and also in the same row vertically, rather than drilling through the middle of a brick and quite close to each other there. So I was just saying that I've been told a different thing.
Great. Okay. I'll actually I'm just going to make note of that in case we can see some various different examples of what you might see. That'd be really helpful, I think.
And also regarding an internal wall installation, obviously one has to take light switches and other things off the wall and extend the cables to the new light switch level. And there's quite a lot of other things that's relevant to. Windows, you have
a bigger recess, yeah.
Yes, for windows and doors. And
yeah, that's a really good point. Thank you.
Chimney breasts and
yeah. Yeah, radiators, plumbing, whatever is on that wall will need to be adapted. Yeah. Roger, did you have a question? Or
yeah, well, there's a couple of points. The first one is that at the launch of our energy campaign on the 16th of November in Ixworth, one of the exhibitors there will be a company based in Cumbria, which manufactures insulation materials mainly from natural fibres, including wood straw and hemp and various other things. What I've seen of that material is it's very comprehensive. It's likely to be more expensive, I think, than some of the more regular choices, but it's likely to last longer. And one of the other features of doing external walls is that you often have to alter the roof because the roof may not come out far enough to keep the splashing of rain off it. And that's particularly true on the corners, that you may need to modify. There may need to be a modification there to stop the rain running back into the new insulation. But it's very effective. And in fact, in Suffolk, most of the work that's been done for less wealthy households, where it's been done for them for free, has used external wall insulation, and they've made a good job of it. It's very good.
Really good to hear. Thank you for adding those points and sharing that. Did you say when was that coming up, the event?
16th of November. Starts at 10, finishes at 1. And we have about a dozen or so exhibitors from both the voluntary sector, the local authority funded organisations like yourselves, and some commercial companies. There's Greenscape, for example, addressing the issue of solar panels, batteries, home chargers. Yes, and Suffolk County Council addressing the question, for example, of electric vehicles and public chargers. So there's quite a range of issues that we're addressing, as well as insulation.
Right, I'll try and add it into the list of notes that we'll send around. Thanks, Roger. Excellent. I'm aware of the time, and I don't want to go over. So I'm just going to try and whiz through the next few slides, but please do feel free to add questions, which we'll pick up at the end, or raise your hand and we'll pick up our questions as we go along. So when we're looking at savings that we can find from cavity wall insulation, this is again from the Energy Saving Trust. This is looking at the various different households along the bottom again, and annual savings along the on the left, the vertical axes. So a detached house typically can expect about £410 worth of saving a year. It's again based on a gas average household. But again, like I said earlier, oil based houses can expect a similar savings based on the cost conversions. Whereas if you look at like a mid-terrace house, you're looking at more like £140 saving with cavity wall. When we're looking at solid wall, you can see some of the examples of savings there. So for about 550 for a detached house, £190 per year for a mid-terrace house. Great. So we'll look at draft proofing next, and see which tips we might want to share with residents and householders. So obviously draft proofing can be some of the cheapest and easiest ways to cut energy costs around the home. We've seen some of the examples already shown and shared around the group. But obviously the aim is basically to stop cold air coming in and prevent warm air from escaping. In this image that you can see on the bottom right hand corner, the actual kind of the heat is being lost through the windows and the doors. It's a bit of an extreme example to actually show and demonstrate, which you might pick up on when you start to see the images that you're using yourselves. But if we try and tackle draft proofing, we can actually see results of about 10 to 20% savings per year. So it's quite a nice quick win to try and put in place as a starter. So some of the types of things, Lara's shown a lot of these in that goodie pack you've put together, but you've got obviously insulation strips that you can put around exteriors of doors or windows. Letterboxes is another place that obviously can let in quite a lot of or let heat escape, or the other way around if it's that way around in summer, but I think it's often overlooked, that space. So and also keyhole coverings as well, that can actually blow quite a gale through those. Windows, obviously you can fit with the type of film that Lara was showing a little bit earlier, to seal those in. Interestingly, loft hatches are ones that we often see kind of overlooked. So using strips of draft excluding material fitted around the edges of the frame, and then obviously insulating the hatch itself can stop and reduce heat loss up to the attic spaces. Yeah, we've got draft excluders there on the bottom that we mentioned, and various different ways of doing that. Unused chimneys, fitting actual draft excluders that are kind of like little pillows that you kind of pop up the chimney and then pull the little handle. Some of them have different mechanisms, but they can stop quite a lot of heat just simply going up the chimney. Obviously a note there to kind of remember that you've got it up there if it's a fire that's in place and actually being used, because you want that still there when you go to use the fire again. I think some other things that I've personally found when I used to live in a flat in my last home, things like just simply drawing the curtains and keeping that energy from escaping in that layer just at night made a massive difference. I really overlooked it, and yeah, we saw on our smart meter the difference that it made every night. And something that we're now doing in the house that we're in, it's a job that we've got to do. We've got beautiful exposed floorboards, but they have huge gaps in between. So we will be filling those gaps and making sure that we have less drafts. Great during the summer, but less great during the winter time. So something else to maybe think about, depends on the property that you're looking at. Other ways to save energy when we're looking at a household as a whole and actually reducing those energy bills. Obviously, LED lights are a big one, really quick win. A lot of people have changed over, but there are a significant amount of people that are still using the old style incandescent or fluorescent lighting. So they use, obviously, or LEDs use 90% less energy and can last up to 25 times longer than the traditional type of bulbs. And the savings, although they are a lot more expensive to put in place and switch to, you can normally make the savings up within the year period from the reduced energy bills. When we're looking at lighting, obviously other things to think about are timers and dimmers, which can also save electricity as well. Other things to think about are smart thermostats, room thermostats, obviously allowing people to actually control the temperature within their home when they're not there. Just even a few hours a day can make a big difference. Sometimes bleeding the radiators, making them work more efficiently, can make a difference, and turning down the flow temperature of the boiler and not allowing it to just kind of be in the highest temperature setting in the kind of very depths of winter can make a difference. Otherwise, it's just needlessly heating up water and it can get to a very high temperature, wasting energy quite quickly as well. Great. Does anyone else want to share anything else that they want to add in? Yes. Go on, Laura. Do you want to go first?
I'm really quick. I know we're running short of time, but this is the 10-inch sheep's wool chimney locker.
Yeah.
And it has a handle that you can either have half there or a full length one there. It joins in the middle, and then the idea is that this is swinging down underneath in view of the chimney to remind you to take it out when you put the fire.
That's very handy.
and not to put it back until it's all totally cold. Obviously, you can get round ones and rectangular and square and other shapes as well. So that people know and have seen it. It lodges into the chimney to so it needs to be bigger than the size of the chimney. That's all.
Right. Yeah, and that's nice to see that design. We've got one that looks like a pillow, and like the actual handles are kind of lost up the chimney. Luckily, it's one that we don't use, the fireplace, but yeah, I always forget that it's there. Thanks for sharing. Roger, did you want to share something?
Yeah, it's your comment concerning your floorboards.
Yeah.
Usually, if you've got floorboards laid on joists, then it means that air has got free access to the area below.
Yeah, thank you.
If that's the case, then those floorboards will expand and contract dependent on humidity and temperature. And you really shouldn't close the joints because you'll find the boards will crack and rise.
Yeah, so
you're probably better off, if you can manage it, to put rugs or carpet on them, because that will seal it and give some added insulation.
Right, that's a good point. We've got quite our gaps are quite extreme in our house. I think we need to look at some some material that allows that flow of air, but also which I'd meant to mention, but also kind of like allows for that expansion.
Well, tongued and grooved boards, that's why they're tongued and grooved,
yeah,
because it does allow them to expand and contract while still keeping a reasonable seal.
great. Thank you for sharing. Excellent. Right. So other ways to kind of save energy when we're looking at this aspect, kind of boiler upgrades. They typically say a boiler needs replacing every roughly 15 years, depends on the boiler type, make, model, and year, obviously. When we're looking at kind of replacements, what we might want to be looking at replacing it with, even just new and more efficient boilers can have a huge saving difference. Or if we're looking at a completely different system, potentially we want to go for a lower carbon heating system, such as a biomass boiler. In some situations, they can work really well, or heat pumps potentially. We're not going to go into these in too much detail, but here's a little chart at the bottom, which basically shows the difference of when you're upgrading a heating system, going from a D, E, or F or G rated system on the left-hand side, and switching it to an A rated model. Or you can see the different house types along the top there, and actually just see how much savings those upgrades can make. Again, it's based on a gas heating system upgrade, but it's very similar for boiler upgrades for oil as well, if you can't change the type of heating system that is, because obviously oil will have a huge impact in its carbon impact. This one just highlights that difference for oil. So you've got the oil boiler efficiency at the bottom. You've got boilers that are 60% on the far left, up to 95% efficient on the right hand side. And then you've got the annual oil consumption going up on the vertical axes there in litres of consumed oil. And you can see the difference between a 60% efficient boiler, which is more of your kind of G-rated boilers, to a 95% boiler efficiency can make a big difference in saving. That's about £921 worth of savings there. So yeah, just upgrading and making sure that you've got boiler systems running as efficiently as possible can make a difference. Great, I'm going to move on to renewable energy. Any questions at this point? Seems like okay, great. So just going to really quickly talk about two renewable energy solutions. We're not going to go into too much detail, but just to familiarise terms for anyone that's watching this that hasn't come across too much detail about these. So solar PV. These are solar panels that they go on people's roofs, sometimes ground mounted as well, but they work by capturing the sun's energy and converting it into electricity that we can use within our homes. The solar PV systems themselves are rated in kilowatt peaks, or kWp, and this is the maximum rate of electricity generation at its peak. So the kilowatt peaks of a solar array basically depends on the size and the type and the number of panels, but what you could typically expect for an average roof is about 3 to 4 kilowatt peaks array as being an average, which can provide a domestic household for quite a good portion of its energy. Obviously with solar PVs, we want to kind of, oh my ghost there, sorry. We kind of want to maximize the energy that's generated from our solar PVs and make sure that when it's generating the energy, during the daytime, we're actually running all of our higher energy appliances like washing machines, dishwashers, for example, and using that energy. Obviously, if we generate energy that we are not using, we can sell it back to the grid as excess energy. And something to note, obviously, solar batteries can be useful depending on how much energy we're generating from the panels. Depends on whether it's going to be cost effective, but obviously they can help us make most of that energy that otherwise would have gone to the grid and actually use that at night time to help us save on our energy bills. We won't go into too much more detail than that, but if you have any questions, do pop them in the chat and we'll pick them up at the end. Air source heat pumps. Obviously there's also ground source heat pumps as well, but they're much less common that we come across because they need a lot of space outside typically to be able to work. So we'll just focus on air source heat pumps. When we're talking about air source heat pumps, and if you want to go into any more detail on this and find more resources, Get a Heat Pump is a new website that's been launched recently. It's full of loads of useful tips. So I'd highly recommend that resource. You can just see there on the slide on the top right hand side. The way that air source heat pumps work is kind of transferring the heat from the kind of outside air to a water system, which heats the room via radiators or underfloor heating. And it can also heat water stored in a kind of a water cylinder for obviously the hot tap, showers and baths. That's a very simplified version of how it works, very, very simplified. But that's all, yeah, you need to know to be able to kind of introduce the topic of heat pumps to people. The main thing with heat pumps is their efficiency, so over conventional boiler systems. So they use a very small amount of electricity, but actually produce a lot of heat for that smaller amount of electricity. So we can actually often achieve 200 to 600%, depending on the system and the setup, efficiency of the actual system compared to, say, for example, an A-rated gas boiler, which actually has about a 90% efficiency rating. So when you're thinking about using energy in the most efficient way, heat pumps are the most efficient method of heating. Obviously, it works best if the house is insulated. There are examples that I've seen where the system has come first and then the insulation has come second, but it has to be designed for a particular tolerance for the insulation that's going to come retrospectively. But that's all for a heating engineer to work out and balance the system properly. But obviously, if we can, insulation first and then heat pumps is always advised. They can work well when accompanied with solar panels, as obviously the electricity that we generate from the solar can obviously be then used to heat your home. But obviously just bear in mind the times that we're going to be kind of using the heat pumps and kind of when it might be in most use in the or working more potentially in the winter when there's less solar there, but they can work very well together. There's a government boiler upgrade scheme, which grants up to £7,500 towards the cost of a heat pump. And we've got more of that info in the last slides as well to share. So there's not anything else that I'm going to share on those two topics at the moment, just so because you don't necessarily need in your roles to know anymore. But if you do want to kind of get involved in any more detail, or if it raises any questions, Get a Heat Pump is a really, really good resource to use. There's other various ones that we recommend as well, and I can pop those in the notes that we'll send around as well. So the last section, which I'm going to really quickly whiz through and try and finish at 7:30 for everyone. Thank you for bearing with us while we go through this session tonight. It's all just around communication and funding. So just some examples of how we might want to reach out to people and what to do next. So when we're making our local connections, obviously we might be already very well connected within our communities and know where to go to reach individuals and households. But if we need to think about what might work, and some examples from what's already worked from other groups, we've got obviously reaching out to already established local groups, so church or other religious groups, parent toddler groups, men's sheds groups can be really handy for getting to people that are in need. Local magazines, you would have been given a template for article for local magazines and newsletters as well to help you start that. Social media is a really good one for localized like Facebook notice board groups, and for those people that are not on or a little bit more hesitant around social media, Nextdoor can be a really good site to share information on and reach out to people. There's been good examples shared through various training sessions that people found by linking into repair cafes and food banks, because you're hitting a lot of people that are, or you're reaching a lot of people that are actually kind of in need of a lot of help, and you can try and kind of present a different theme of support that they might not have thought about where to go to for it, and reach out to them there. Parish and town council meetings, sometimes they might not sound the most thrilling of spaces to go to, but they can be really helpful for connecting to people. Obviously local events, so like Christmas fairs. Jess was saying that they've got a roll-up banner that you can actually borrow if it helps kind of communicate and kind of draw people over to what you want to be sharing with people. Obviously local notice boards, and again, you'll have been given a template flyer for this to post through your doors. Obviously you can adapt anything if you need to for your local space. And warm spaces, so the network we'll share in a few slides time, and connect you to people obviously that are in need of warmer spaces and warmer homes. So they could be quite good spaces and places to go to. When we're starting conversations, just some things to be kind of mindful about. Obviously, being polite and friendly, I'm sure we would all have this in as our second nature, but just approaching the conversation as positively and friendly as possible, kind of smiling, making eye contact where we can, and using polite language to make them feel comfortable and receptive to all the information that we're sharing, really puts us off on the good foot when we're starting these conversations. Understanding motivations, and the second point here, as we're going around this circle on the right hand side, kind of finding a common ground. So understanding what might be shared concerns between yourself and the householder, or interests. So is it costs? Is it something else that they're concerned about that actually these changes can help them with? Highlighting benefits, so talking about the advantages and of energy saving measures, and mention kind of cost savings, or like all the different aspects to it. So it could be improved air quality as well, or enhanced home value. Sometimes we might not be able to get through to anyone else on the other points, but home value might appeal to some people. Simply signposting to information, like I said earlier, makes the next steps a lot easier for people to access. Sharing success stories, so just talking anecdotally about things that you've done at home or that your neighbour's done, so that it makes people, it encourages them to take action, and it actually makes it seem real and achievable to them. And obviously personalising conversations, so tailoring it to specific households, and kind of, understanding what their concerns and challenges, so that it's relevant to that actual need of that person. I've really whizzed through that. I'm really sorry to just throw that all at you, but I'm very conscious of the time, so we'll carry on. So the last little bit is just about grant funding. So we want to end on a positive note. There are lots of different grant funds out there available to help various residents, depending on what it is that you're wanting to be looking at. So as I say, we're not going to go into the detail, but the slides will be shared, so you can go through any of this at a later date. So we've got the Suffolk 0% green loans, which can help with spreading the costs of things like solar panels, renewable energy measures that are more difficult for people with upfront costs. You've got Warm Home Suffolk as well, which can provide a lot of different help for homeowners, renters and landlords. There's the eligibility criteria there, and this will be changing coming up soon. So the advice is to keep up to date with the Warm Homes website there at the bottom of that slide there. The next one that is very hot off the press as of this week, I think, Jess, was it? The Suffolk loft insulation offer. So it's not means tested, it's for anyone in Suffolk. Basically, anyone can get a 50% discount off of 200mm or 370mm wide eco-friendly, itch-free thermal insulation rolls from High Loft, and it's up to £200. There's the link that we'll share for that for the discount code. So that's quite a good offer to take advantage of if it's roof insulation that you're looking at. For Mid Suffolk specifically, we've got the Suffolk Cozy Homes grant, and then on the right hand side for West Suffolk residents, we've got Healthy Homes Advisor, which is a free energy advice surveys, and they can kind of come out and conduct surveys and recommend different measures, which can be quite a helpful starting point for people. And then the last few, so the government kind of national schemes that we've got going on, the Great British Insulation Scheme, and we've got Connected for Warmth as well. Again, you'll get the details in your side packs. And the last couple, so we've got the boiler upgrade scheme, which I mentioned a little bit earlier. So it's basically to help with the costs of installation costs of kind of heat pumps, and in some cases biomass boilers as well. And then the last one here is actually a little bit less well known, we find, but it's actually about an interest-free loan for heating oil, which can take some of the edge off of the energy costs that people are facing, especially those in rural areas. For further advice and information, we've got Citizens Advice, you've got Warm Homes Discount Scheme, just to be aware of that automatically well, it takes it off of a prepayment meter. And then you've got the National Energy Action Support Service as well. All really good support systems there for people. Warm spaces, which you've mentioned already, but it's just a network across Suffolk in particular of different spaces where people can go to just be in a warm space. There's lots of different places registered across this map, and you can go to those through the link. And we've listed various different sites that I've keep mentioning throughout this session, but you've got the Energy Saving Trust, Centre for Sustainable Energy, Historic England, and you've got your own dedicated site as well for the thermal imaging training and resources on which this recording will be posted as well. And if you're interested, we've got the free online course. If the climate change awareness side of this really sparks your interest and you want to learn a little bit more, it's obviously not something that is mandatory in any way, but if it's of interest, there's a free online course which can help with improving awareness. Great. Thank you for bearing with me while we just got through that last little bit of the session. I will just go to Q&A now, but please feel free to unmute yourselves and share any questions or examples of anything you want to share. Roger, please go for it while I'm opening the queue.
It was just a point on older buildings and buildings in conservation areas. There's a English Heritage have just published an update of their guidance on how to address the issues, including planning problems, which I found very useful.
Excellent, thank you. Thanks for sharing that. I think the more that we find that we can share actually to make things easier, it makes a big difference. It looks like, Jess, thank you for picking up some of the questions in the Q&A. Looks like we've addressed quite a lot of them. Just going to check if there's anything open. Jonathan, thank you for sharing those. The spray foam insulation link as well. That was great. Perfect. Has anyone else got any questions before we leave? Lara, did you want to add anything?
Hi, yeah, I was trying to find the source of it, but I can't. So I spotted a Facebook link for free solar panels or something on your roof. And had been talking to a neighbour yesterday, so I thought I'd ask on their behalf whether it's possible. And the upper age limit for this particular company, which I can't remember yet what their name was 74. And my two neighbours are 90. So they didn't qualify, and I said, my goodness, I didn't know that. Why 74? And she put the phone down on me. So I just wondered if anybody else has heard of anything like that.
Yes, most of these free offers are in fact effectively leasing your roof. And the problem with it is you don't get very much recompense for it. And if you come to sell, then the lease is for as long as the lease is, and it may make the property difficult to sell.
Right, yes, of course. Thank you. Yep. Thanks, Roger. So it's not a great offer, really, is
No.
it?
No, somebody else will be making the money out of it rather than you getting the benefit.
Thanks.
If it's free, I always question it.
Good motto.
Except, of course, when it comes from a local authority.
Good caveat there. Great. Thank you so much all for sharing everything tonight and adding examples and insights along the way. Is there any last questions before we wrap up? I think we've been on it with the questions. Thanks, Jess. If anything comes to you, please do feel free to pop myself or Jess an email. We will obviously send the slides out in slide format. You'll have the obviously recording if you need to go back to that and the notes. So yeah, hopefully that will help answer any other questions that might have popped up. But yeah, thank you all for your time. I really appreciate you joining us this evening. And thank you for all your work that you will be doing. I hope you have a good fun with the cameras and it provides a really good resource going forward. Thank you all.